This video is for lesson 4-2 about angles and angle bisectors. Learning goals are to apply the angle addition postulate to find angle measures and to use the definition of angle bisector to find angle measures. The tool that we use to measure the size of angles is called a protractor, and you see a picture of a protractor on the screen. The number of degrees in an angle is called its measure. There are some angles drawn, and then the protractor is laid on top of the angles. Question 1 says, determine the measure of each angle. When you look here at question A, you'll see this little lowercase m. That symbol means measure. And then this little symbol here means angle. So this is asking us, what is the measure of angle AOB? So we want to find angle AOB. It goes from A to O, and then bends a corner and goes towards B. So here is that angle highlighted on the screen. Notice that the protractor is positioned on the angle so that one side of the angle goes along this guideline on the protractor. And then starting here at 0 and swinging up around the outside of the protractor, we find the size of the angle by looking to see at what number the other side of the angle is touching at. So we would read the number off this spot on the protractor. I kind of drew through it, but right there it said 50, and so that's 50 degrees. Question B, find the measure of angle BOC. So start at B and go along the segment until you get to O, and then bend the corner and head to C. B is at this number right here, which is 50. And C is crossing the protractor at this number, which is 90. If we want to find the measure, we subtract those numbers, 90 subtract 50, and we find out that that is 40 degrees. We would determine the other measures in the same way. Find out where both sides of the angle is crossing the protractor, and then subtract the two values. Number 3, use our results from the previous questions to describe any patterns we notice. So number 2, I filled in the measures from a protractor, and I want you to look for patterns. Angle TQP is this angle from there to there. It's 115 degrees. Angle TQR is this angle from there to there. It's 24 degrees. And angle RQP is the angle from here all the way across to there, and it's 139 degrees. Notice that this angle includes the other two angles. In fact, these two smaller angles put together make the total distance of 139, and that's the pattern that we notice. The two smaller angles sum to the large angle. That's the angle addition postulate. If you draw an angle and then you make it into two angles by dividing it in some place to create two angles, the two smaller angles, angle 1 and angle 2, will be equal to the large angle. Maybe that one was called number 3. That's called the angle addition postulate. Number 4, given that point D is in the interior of angle ABC, describe how to determine the measure of angle ABC without measuring anything. If we know the measures of angle ABD and DBC, it'll help if we draw a sketch to visualize this. This talks about angle ABC. So let's draw some angle to be ABC. A, B, C. Point D is in the interior of this, so somewhere on the space inside there, let's put another dot called D and connect it to B. That just split the angle into two smaller angles. So without measuring, how can we find angle ABC? We could take the measure of angle ABD and add the measure of angle DBC. The two smaller angles in the large angle add up to the size of the large angle. Here's another practice problem, number 5. Use the angle addition postulate in the given information to complete each statement. Question A, if P is in the interior of angle XYZ and we're given some measurements, then find the measure of angle XYZ. It will help if we draw a sketch of this. So let's draw some random angle and label it X, Y, Z. We're told that P is in the interior of the angle, so somewhere in here, put a dot and connect it there to split up the original angle into these two smaller angles. Now let's do some labeling. Angle XYP is 25. So X to Y to P, we got to find where that is. That one's 25 degrees. PYZ is 50, and that goes here. The question is, how much is angle XYZ? How much is the large angle if that one's 25 and that one's 50? Add them together and you'll find out it's 75 degrees. I'm going to pause the video for you to try question B on your own. Here's the answer. The measure of angle MTD is 25 degrees. And here's why. Over here on the left side of the video, I've drawn angle RTD, then located point M in the interior to create two angles. RTM gets labeled 40 degrees, and RTD, which is the large angle, is 65. We're asked for this missing piece here. So 40 plus what number makes 65? And that answer is 25. Question C is another one of these, but this time some of the angles that are given to us have some algebra expressions in them. So let me do this one as a sample. Question C talks about angle EFG. I'm going to draw angle EFG. We're told that point H is in the interior. So maybe here can be point H and connect it to the vertex. Okay, now some labeling. EFH, E to F to H is 75 degrees. HFG is 10x. EFG, which is the large angle, is 20x minus 5. So to label the large angle, let me draw kind of a big loop like this so that I can label 20x minus 5 on there. We want to find the answer for x and then find the answer for angle HFG. The picture helps us to create an equation. We can see what the two small angles are. Those are the ones that add together to make the large angle. So the equation would look like this. The 75 degrees plus the 10x equals the 20x minus 5. Let's solve this. We can subtract 10x from both sides to get 75 equals 10x minus 5. Then add 5 to both sides to get 80 equals 10x. And then divide both sides by 10 to find out that 8 is equal to x. That was one of the things we were asked to figure out, so we know this answer is 8. Okay, now angle HFG. In the drawing, from H to F to G, that's the one that has 10x in it. That's where we fill in x is 8. 10 times 8 is 80 degrees. There's a vocabulary word in this section, the bisector of an angle. The bisector of an angle is a ray that divides the angle into two congruent adjacent angles. For example, in this drawing, if we have the original angle ABC and then draw ray BD right through here, if this angle and this angle are congruent, then ray BD is called the bisector of the angle. Number 6, given that ray AH bisects angle MAT, determine the missing measures. It will help us if we make a sketch of this. So let's draw angle MAT. Any size angle you want. We're just trying to sketch to see where things are positioned. We're not trying to get them to be actually the right sizes like 70 degrees or 80 degrees. We want to put H right exactly in the middle between this side and this side so that when we draw in the ray, it looks like it splits the angle into equal sized pieces. This was ray AH, so that dot right there was H. We want it to look like that is congruent to that. Make them look identical. Okay, if angle MAT is 70, if the large angle is 70, how much is MAH, which is just half of the large angle? That would be 35 degrees. Question B, if angle HAT is 80, so HAT, this one right here, if that's 80, how much is MAT, the large angle? If that's 80, then so's that piece. And 80 plus 80 makes the large angle 160. Here's another example problem where it says try these. Given that ray FL bisects angle AFM, determine each missing value. It always helps to sketch what's going on. So here is angle AFM. We're told that segment FL bisects this. So we want to draw a ray right through the middle. Try to get them to visually look like equal angles on both sides of that ray. Somewhere on the ray there's a dot and it's called L. That's ray FL. Let's do some labeling. LFM is 11x plus 4. AFL is 12x minus 2. Find the value of x and then find these angle measures. By doing the picture, it helps us to see the relationship we need to create an algebra equation. Because these two things are congruent, the algebra expressions are equal to each other. We can write 12x minus 2 is equal to 11x plus 4, and then solve the equation. First step, subtract 11x from both sides. 12x minus 11x is x. Then add 2 to both sides, and we get x equals 6, which we can fill in on the blank. Now we want to know angle LFM. So look in the drawing. LFM has this expression. That's where we fill in 6. So 11 times 6 is 66, plus 4 is 70 degrees. We're also asked for angle AFM, but we have to know what that is. So you look in the drawing. A to F to M, that's the large angle. If just half of the angle is 70, then that large angle is 140 degrees. I'm going to pause the video for you to try question B. Here's the solution to question B. Over here on the left side, I've drawn angle AFM and then drawn ray FL to split the angle into equal sized pieces. I want that to look the same as that. I've then labeled 6x minus 2 as the large angle and 4x minus 10 as one of the small angles. Remember that if that is an angle bisector, then the other small angle is also 4x minus 10. Now we can create our equation. The two small angles added together make the large angle. And so here's my equation. 2 times 4x minus 10 is equal to the 6x minus 2. Let's solve this equation. We can divide both sides by 2 to cancel away the 2. And we have 4x minus 10 equals 3x minus 1. Now we can subtract 3x from both sides. 4x minus 3x is x. And we can add 10 to make it move to the right side. Negative 1 plus 10 is 9. We have x equals 9. The other thing we were asked for is angle LFM. So looking in the picture from L to F to M, that has the 4x minus 10, and that's where we fill in x is 9. So 4 times 9 is 36, minus 10 is 26 degrees. I'd like you to work on number 7 because complementary angles is a review topic that has actually been on a couple quizzes now. Complementary angles sum to 90 degrees, and that's the hint that you need to be able to make an equation with the two angles. So please make your equation, solve it for x, and then find the measure of each angle. Here's the answer. 3x plus 7 plus 6x plus 11 equals 90. This is the angle A and this is angle B, and we're adding them together and saying equal to 90 because they're complementary. 3x plus 6x is 9x, 7 and 11 is 18. Then subtract 18 from both sides to make 72. Then divide by the 9 to get x equals 8. Take that value for x and substitute it in here to get angle A figured out, and substitute it in here to get angle B figured out. We get the answers 31 degrees and 59 degrees. Here are some check your understanding questions. I'll pause the video for you to answer these. Here are the answers. Number 9, ray KN is the angle bisector of angle JKL. Explain how you could find the measure of angle JKN if you know JKL. So if you have an angle called JKL, and then there's a ray that splits that angle right down the middle called ray KN, if you know JKL, the large angle, then JKN will be half of the large angle. And that was my answer. It's half of angle JKL. Number 10, in this diagram, we have angle 1 with an algebra expression, and angle 3 has an algebra expression. How could we find angle 2? Because angle 1 and angle 3 are vertical angles to each other, they are the same size. So we could make an equation by saying that the 4x plus 30 is equal to the 2x plus 48. Solving the equation gets us an answer for x. And then substituting that value of x into one of these expressions finds out the size of angle 1 in degrees. If we know how many degrees angle 1 is, we can find angle 2 because angle 1 and angle 2 together are creating this straight line. They're supplementary. Supplementary angles add to 180. So if you know angle 1, angle 2 is whatever amount of degrees are needed to equal to 180. Number 11, angle RST is adjacent to TSU. I've drawn an example of that and labeled 40 degrees here and 50 degrees here. Why does the angle addition postulate show that this angle is a right angle? And it's very straightforward because 40 plus 50 is 90, and that's what a right angle is. In this lesson, we reviewed the angle addition postulate about adding two smaller angles together to equal to a large angle. And we discussed an angle bisector, which is a ray that splits an angle perfectly into two equal-sized angles.